proteomics is playing a really critical role in biomarker development across a broad spectrum of diseases. So I think fundamentally proteins are one of the most important molecules to measure in blood, although that is challenging, but I think we're making significant inroads to being able to do that. I think there are a number of disease areas in which there's a really continued clinical need for new biomarkers, not just new biomarkers that we could discover, but ones that could go to the clinic, and particularly in diseases like prostate cancer, where there are massive numbers of men, in this case, who are diagnosed with the disease, and we need better biomarkers to guide the treatment decisions that will impact on their health. Obviously, there are lots of different views about whether mass spectrometry will reach a clinical setting. I think that, so I was taught biochemistry as an undergraduate, and I was taught chemistry, and I was taught mass spectrometry by an individual who'd invented a technique of mass spectrometry called fast atom bombardment mass spectrometry. And as an undergraduate, I couldn't get to grips with the technique, and I vowed that I never wanted to do it. And I think that over obviously the intervening years, it's become apparent that you can't do proteomics without mass spectrometry, certainly in its current form, and that mass spectrometry is critical for that. So although I have a sort of an inbuilt bias against mass spectrometry from an undergraduate perspective, I think the realization is that it is going to play a fundamental role and that it will get to the clinical setting. So I often tell some of the students that I talk to that when you go through an airport and you have one of those white discs swabbed against you, it goes into an instrument, and that instrument's a mass spectrometer. And that, I think, breaks some of the biases that these are really complicated instruments that you need to be really highly trained and skilled to operate in, and that they need to operate in very specific environments, and clearly they don't. And I think that in recent years, and even just in this year, there have been some really significant developments that mean that mass spectrometry is now in a clinical setting. At the moment, it's just for small molecules and metabolites, but I think the expectation is that that will be extended to peptides and proteins, and that it will achieve full clinical diagnostic utility. So I think that the key development really is to identify the clinical need. This has always been our perspective, because there's no point trying to do lots of research and potential developments around something that's not actually going to become a product. So I think one has to identify the clinical need and then develop a test that's going to meet that clinical need. And if that test is best performed by mass spectrometry of peptides or proteins in clinical samples, then I think there's a reason for developing it. So I think that some of the developments that we've seen in recent years are making more robust targeted mass spec assays, and making it clear that you can do those, you can routinely perform those assays on mass spectrometers that are already used in a clinical diagnostic setting. That there are a number of companies who've developed triple quad mass spectrometers that are much more like a clinical analyzer than they are a lab-based triple quad instrument. And I think that when you bring those developments together, then you have the opportunity for doing these targeted mass spec protein assays. So I think that in our experience, the medical doctors, and so we speak daily with urologists and rheumatologists and pathologists, and as long as you can show them the data that's robust, I don't think they really care how you generated that data. So if you talk mass spectrometry to them and start trying to explain mass spectrometry to them, you're wasting your time, because they're not really interested. What they really need to see is the data and how that relates to the clinical scenario that they're interested in, and how that would impact on patients. And so it needs to be explained to them in terms that don't require them to understand or know. As long as they're confident that the data is robust and reliable, it really doesn't matter how you generated it. And so I think that one of the things that we probably try to do is to get them interested in mass spectrometry and how we did the tests and the technology, because we're interested in it, and they're not. In my experience, they're not. They're much more interested in the data and how that impacts, and how they can combine it with their clinical data, and then how it'll impact on the patient. Am I satisfied? I think as the organizer, I'm probably the last person to ask about how it's going, because I have a very distorted perspective on things, and I obviously seeing things because I can see all the mistakes and all the things that should have been happening that haven't been happening, whereas I think that a lot of the delegates hopefully aren't seeing some of those omissions and slight errors. I think in general it's going very well. I've had a lot of positive feedback. I'm sure once things have settled down, we'll start to hear some of the some other comments and I think that we can learn from those comments, and I think HUPO can learn from those comments so that the next Congress improves on those, and we learn from those mistakes, because there are bound to be mistakes or things that didn't work well. In terms of organising it as an individual, I don't think you can organise it as an individual. It has to be part of a team effort, and I've been really fortunate to have a really good team working with me, and that's a team of people who are actually prepared to do things, and of course they're all doing it voluntarily, and so it's a great team effort. I think one of the things that I've realised is I've learned a lot about myself in doing this, but also a lot about individuals, and a large number of individuals. And in general, it's, both of those have been really positive. It's a great community, a lot of positivity, a lot of very energetic and helpful people, and so it's been a great experience to organise it. Yeah, so I think the HUPO Congress stands out because, and this I think is one of the challenges in organising a HUPO Congress, in that it covers a broad spectrum. So it covers both the technology and the detail of the technology. It covers the applications of those in the research laboratory, and increasingly it's covering the translation of those to the clinical setting. And so that means that there are a number of different constituencies involved, and you have to, in organising a Congress, you have to try to bring all those constituents together. So it's a much more holistic view. It's not focused on one disease, it's not focused on one technology, and so I think that is one of the things that's unique to it. I think increasingly, and I hope that HUPO 2017 will have contributed to that it's less inward looking than it has been or could be in the past, and has been in the past, and many congresses are, and it's more outward looking, about engaging even more constituencies. And so, there's the constituencies involved around those people who can handle and generate big data. We're a few hundred yards away from the European headquarters of Google, yet they're not at the conference. And it would have been really nice to have them at the conference, and we tried. So I think, that it's really good and it's unique already, but I think that it's got the opportunity to grow. That'll make it even more challenging as you bring more of those constituencies on board, but I think that's a challenge and an opportunity for the future. I'm also, I think it's really clear to me that we're not really well represented here by the pharmaceutical industry. And so I think in the future there'll be a greater re-engagement with the pharmaceutical industry, because I think proteomics, having developed now to a particular stage of maturity, is, I think, ready to re-engage really to a much greater extent with the pharmaceutical industry in a new way. We heard a wonderful talk of Leroy Hood about how that is going to change, and I think that we're at a position where we can take advantage of that change. It depends what you call the human proteome. If you define the human proteome as identifying and characterizing to some extent the encoded gene products of the human genome, then maybe we will. I think it's sort of slightly, so that's a really valuable thing to do in its own right. And I think it's really good it would be really good to have assembled that resource. But of course, the same, having assembled the human genome, it's clear then that there's much more to the human genome than just the coded sequence. There are modifications, and there's expression of various components of that genome in different cells at different times and in different disease states. And that's the really interesting thing. And I think it's the same with the proteome. It's it'd be great to catalogue, if you like, the base level of what we're working with. But ultimately, when you want to analyse the human proteome, you really would want to analyse all 200 post-translational modifications of every protein that's expressed, their locations, their temporal expression, their tissue-based expression, and how that integrates with the expression of metabolites and other molecules. So will we ever do that? I think that's a long, long way away. But that's not to say that we can't do very useful and valuable things in the meantime. So my PhD topic was on insulin signaling and lipid metabolism. So I started life as an undergraduate chemist and got a lecture. I did a module in cell biology and got fascinated with that. So it was in insulin signaling. And I suppose that did lead me into proteomics, because it became apparent to me that with tyrosine kinase receptors that are cell surface bound, if they were influencing transcription in the nucleus, there were two ways that could happen. One would be by soluble molecules moving into the nucleus, and they're affecting gene transcription, and the other would be the migration of proteins into the nucleus. And so we started to look at migration of proteins from the cytosol into the nucleus in response to tyrosine kinase mediated signaling. And so we started to isolate nuclei and look for proteins, and that was the start of the proteomics work. So I suppose indirectly insulin signaling led me into proteomic analysis in those very early days. So the things that I think are most important for young researchers is to be outward looking. And I think that sometimes we spend too much time in our own laboratories. I think the thing that's had the most significant impact on my career in recent years is actually getting out of the laboratory more, and I think that can be either by spending time in other laboratories or going to meetings that engage with other constituencies, that engage with clinicians or engage with technologists. So for me personally, that's been the most positive thing that's influenced my career, I think in recent years. I think the challenges with careers are always that it is a bit of an up and down, and it will always be an up and down. I think the challenges that young investigators face now are much harder than the challenges that I faced, because I think that the constant demands to be productive are very, very challenging. I think there was an acceptance in the past that investigators would very often go through a fallow period, and if you read books that have been written on the subject of progression of research and academic careers, then the very best researchers, the very best academics, had significant periods when they appeared not to be doing anything. But of course they were doing things, they were thinking, they were formulating new ideas, they were building, stories that they were going to investigate, they were developing hypotheses that they then subsequently went on to test, and those were really significant. So I think the challenge now is, as I can see it, that individuals really don't get those same opportunities to step back and look at what they're doing and have a period in which they may not be, from externally, and certainly not by the metrics of today, as productive as they need to be. And I think in the past there was some latitude and understanding about that. Now I think that because things seem to be much more controlled by numbers and accountancy sort of driven motives, that it's very, very difficult for individuals to do that. So I think I was really fortunate in being in that era where you could be, for periods of time, less productive. And if people were being critical of me, and I'm critical of myself, maybe I wasn't as productive as I could have been. And I suppose, because I'm again very fortunate that, and I seem to be living in a very forgiving world. I now have got the opportunity to be productive again. So my children have grown up, they've left home. I find myself now able to do things that I wasn't able to do 10 years ago, and I still have the energy and the passion to do it, and so I'm really looking forward to that. I just wonder whether in the new world, where people, whether they won't have had that opportunity and they'll have to have moved out into other fields and not stay with what really they're motivated and passionate about doing. Where's the future of proteomics? I think it's very bright. I think it's very promising. Where do I see it heading? I'd love to see it, and this could be pretty controversial, I'd love to see it heading a little bit away from mass spectrometry. I don't think, and again maybe this is just my bias as an undergraduate, I don't think mass spectrometry is really fit for purpose. What we really want to do with proteins is not fulfilled just by mass spectrometry. So if we really wanted to analyze proteins at an individual protein level and all their post-translational modifications and their localization. So I think where it's headed, hopefully where it's headed, is the development of some new techniques and new methodologies. And I think they'll come possibly from outside the field of people who are already locked into the existing paradigms of the way proteomics is done. So I'm hoping that it's going to come from outside. I can imagine what it might look like, and their fanciful imaginations. But whether that'll be realised and whether it will actually come from there, I don't know. Obviously there's a huge amount of excitement about getting continuous data or longitudinal data and very large data sets, and that's undoubtedly an area where it will move forward in the coming years, and I'm sure there'll be a lot of value in that. But I just can't help thinking and hoping that something revolutionary will come from off stage and take focus on the stage for a while.